Welcome to the Department of Healthcare Access and Information HCI webinar titled Robots and Robotics in Hospital, brought to you by the Building Standard Unit here at HCI. This webinar will include uses of robots and robotics, code requirements and concerns, examples of successful designs, and tips for submitting a design with the intent of code compliance. Today, we will cover automatic guided vehicles and autonomous mobile robots, cost reduction, uses, code requirements and concerns, compliance suggestions. If you haven't done so already, feel free to download a PDF copy of this presentation available to you in the Go-To toolbox under the handout section. We are scheduled to be here for 1 hour, which includes a question and answer session at the end of the presentation. If you have a question during the presentation, please type the question into the question section of the Go-To panel and we will answer them the best we can. Please be sure to keep your question generic. But if you have a specific question about a specific project, please feel free to email your questions over to regsunit@hci.ca.gov, regsunit@hci.ca.gov. If the presentation experiences transmission difficulties, please log out and log back in using the same login information sent by the Go-To software when you register for the presentation. And we will do the same if we are experiencing transmission difficulties on our end. In coordination with AIA, you will be able to self-accredit for a total of 1 AIA continuing education credit by attending this presentation all the way to the end. You should note multiple staff members from one office should register individually to receive separate logins and certification. A certificate of completion will be emailed from the Go-To webinar to registered attendees who logged in and attended this. Certificates will not be available from HCI. Today, for presenters, we have Nancy Timmins, Chief Fire and Life Safety Officer, Fire Prevention Unit, Office of Statewide Hospital Planning and Development, HCI. Once again, thank you for joining us today. So without further ado, I hand the presentation over to you, Nancy.
Thank you, Monica. I appreciate that intro. Thank you, everybody, for joining today. I can't see you. It would be good to see you, but good to see you in person. But it's good to have you here. So thank you for taking your time out today to attend this webinar. As alluded to, there's credits that can be earned with AIA for continuing education credits or learning credits. So it looks like 1 credit can be earned for this 1 hour webinar. So with that, let's move on. Today, as you know, we're going to talk about the automatic guided vehicles and the newer technology. Well, both really. We're going to talk about some of the older technology and the newer technology because we see both out there in our facilities. But we're going to talk about these robots, these robotics, and how they're used in the hospitals or how we typically see them being used in the hospitals, what the issues are in relation to code, which of course, fire life safety, that's a lot of it has to do with exiting, battery storage, etc. So we're going to talk about some of these issues and then look at the code sections that these would fall under, because of course there's not black and white code that these are going to fall under. So how does that come into play so that when you have these in your facilities or you have these projects, you can take a look at these sections to see how to comply. And then we'll talk about the PIN that we have for this that helps. For those who don't know, our PIN is a policy intent notice. It's kind of like a guide. If you have these, here are some of the items that we'll look at that need to be addressed code-wise. So we'll get into that. Every situation is different. Every facility is different. How these are used are different. Some facilities might use them just to deliver lunches. Some might be to transport soiled utility or the trash, or medications, or cleaning the floor. So there are so many variables that it's impossible to talk about every single scenario here, of course. So we're going to talk about the basics and what needs to happen code-wise and how we can help you through that so that you can get to using these properly in the building without, hopefully without affecting the occupants in a negative manner. So as you can read here, the International Federation of Robotics reports that using AMRs, and we'll get to that in a second, reduces the cost of delivery by as much as 80% and could cut the average steps walked by a nurse or staff really by 3 to 4 miles every day in a typical 200-bed hospital. So the cost savings that they're talking about, that using these robotics could reduce that cost by as much as 80%. A lot of that cost reduction was actually in the due to injury or lack of work-related injuries with lifting, carrying, the walking. You know, it was most of the cost reduction was because of that. Just to point that out. So, whoops, sorry. Apparently my mouse.
When you think about hospital for the most part, you really don't think of a robot.
Sorry about that. Yes, we have a video. There was an introduction to that, but when I switched the slide there, that went. So this is, if you're not familiar with these, this video just shows one example of how they're used with a brief summary of it. So I'll start that again here or continue it.
Robotic system in the basement that actually moves around on its own.
If you're a patient, I think you kind of take things for granted. You need a towel or a blanket or a medication or something. You never really think, how did that get to the nurse's station? This is how it happens here at the Cleveland Clinic.
AGV stands for Automated Guided Vehicle. They have a dispatch panel where they'll be able to tell it, I need this cart to go to this building and this floor.
The sensor in the ceiling reads the cart when it's dropped in its position. They're powered by batteries.
The AGVs run on a magnetic grid that has been placed under the floor, which actually takes the carts from the service center, the 2-block distance to the 7 different depots throughout the hospital.
The vehicle has audible warning, so if someone walks in front of it, it'll tell you to stand out of the way.
We carry anything from your basic storeroom item to FedEx UPS packages, trash, soil, linen, cleaning,
Syringes, medications, toilet paper, tissue paper, hand towels, Coke and Pepsi.
anything that the hospital uses to run and function comes to us first. We run 24 hours around the clock. The only time the vehicles take a break is to charge up. And service to our patients starts here, and the AGVs assist us in providing the best service that we can so that our customers, the doctors and nurses, can provide the best care.
Okay, as you saw with that one, a general idea of how those work. And that example that was shown was the AGVS, the Automatic Guided Vehicle System. And you heard the gentleman talk about there is a guided, it's a guided system. So you'll find that in the floors and the ceilings, GPS, those types of robots move through the facility based on a track system. Basically, you can't see that, but it moves along this track versus the newer versions, like this one, for example, shown here is that cleans the floor. So that's going all over the place. So it's not just going down this straight line, through a corridor or through these specific spaces. It can be programmed to go anywhere. So we've got these different types. These are just 2 examples, but to separate their groups a little bit more. And sorry if you get motion sickness. That video was a little rough that way, so hopefully you could hear the words and close your eyes. But anyhow, so AGVS and AMR. So automatic guided vehicles, that was the example of that first one with that video. Those are actually robotic devices, and robotics is more of a field of study, but they call those robotic devices, and they're not actually a robot. It's the predecessor of an AMR, which is the autonomous mobile robot that you see on the right. We'll talk about that in a second. So the AGVSs are more original, evolving since 1950. And they're located with the fixed elements like magnetic tapes, magnets, beacons, etc. So that, again, that has a predictable route for effectiveness, and it follows along this guided system GPS wise. The autonomous mobile robots are the newer versions. Those are considered robots, and they're much more advanced in software and hardware wise. You can program these to do all kinds of things. They use free navigation by means of lasers, and then that has a certain degree of independence to make decisions in the middle of the work environment without the need for human intervention, which is huge for what we're looking at too. The AGVS are, I'm not saying that those are, you can't use those, but those are going to be more, I don't know the right word to use, but anyhow, you've got the AGVS, you've got the autonomous mobile robot, the autonomous mobile robot, it also can navigate without external guidance and has freedom of navigation and decision making. So you can see, yeah, this one's definitely more like a robot, and it's suitable in dynamic environments where both humans and machines are needed because of their ability to adapt to a changing environment. Where the automatic guided vehicle, it lacks the autonomy to determine or redefine its own route. And it is suitable for workplaces with a large number of fixed tasks as they require the installation of the infrastructure through which they will move. Like I said, the track system is through the floor or through the ceiling or GPS that these follow, the AGVS follow, where the autonomous mobile robot, again, can be programmed much differently. Again, AGVS is a little bit older technology, though obviously it's evolving. So it's been around longer, but it's evolving and more is happening with those and what they can do. And then again, the AMRs are more robotic-like and can maneuver around a bit better. So you've probably seen these in various forms, whether even if it's on TV shows that you watch, but they're used many uses. Like I mentioned earlier, we've got some facilities that might just use them to deliver the lunches. There's a cart that goes through, and you've got staff member with it, takes the lunch into the room, but the cart is pushing the lunch cart up and down the corridor. Or as you see in here, they're restocking some of the rooms or working on patients. They've seen some of those with your robotic surgeries. So, whoops, sorry about that. This is super sensitive. Just some more visuals of how they're used. I don't know if they're quite used like that all the time, but so again, helping patients too. So it's not just about moving the equipment around and supplies around, but also patient interaction. These are pretty grainy showing up here. Sorry about that. This is an example of using it more for supplies. We're going to talk about what works and what doesn't work in using these. So what are our concerns with these code-wise? There are several concerns, and we help the facilities work through to get to a code-compliant design so that they can use these. Because obviously we see these now, we're going to see them a lot more. When we first started seeing these AGVS like 15, 20 years ago in our facilities, it was really difficult to comply with code for these. They're obstructing the corridors, there's storage in the corridor, they weren't as programmable as they are now. What happens when they have to go through a fire door or fire rated door, smoke barrier door. So some of the concerns again include that obstruction of the usable width of the egress system, the potential storage of combustible materials in the egress system. As you saw, some of those, like this one here, you've got materials on there that are the supplies. You could have the trash, like I mentioned. When that's in the corridors, that's definitely combustibles in the egress system. And then delays in the operation of smoke and draft control assemblies and the fire assemblies. Like I mentioned, the doors, what happens when these have to go past doors, and what happens if there's a fire alarm and those doors are closing. They can have cause inappropriate operation of activated fire control assemblies, installation of equipment that's in the egress system, which code prohibits, interference, with the operation of elevators, which could be a problem. You think in fire alarm conditions, your firefighters are going to access those elevators and need firefighter recall. They don't want to have to wait for the robot to get in or get out or move out of the way. So that can interfere with some operation there. And then maintenance of equipment, including battery charging. So as many are aware, and probably have heard us talk about in some of our recent webinars, is the lithium-ion batteries and the fires that happen with those that are significant. And then the code has requirements for the storage of those batteries. Here are some of the sections. This is definitely not an all-inclusive list of the code sections that are involved, or that when looking at these AGVS, AMR equipment. The top there are your chapter 10, your egress system sections. I'm not going to spell that all out, but basically the requirements that your minimum egress widths have to be maintained and unobstructed. And then because we're fire life safety, we also have to enforce the parts of Title 19 that apply to us, and that's this section 311A and B. Those prohibit the obstruction of required width of an exit and the installation or placement of equipment in or exposed to any exit. So having that in any exit at all, not just the reduction of the width of the required width of the corridor. That's one thing that can't happen. But the other is, this says you can't even have anything in the corridor, except maybe like, if you read into it, maybe like a bench or something. So all kinds of code sections that if you wouldn't even be able to have these if you just went by the letter of the code. And then chapter 7 is going to talk about the doors, of course, and how the doors have to operate and be auto closing. So if we went with just the letter of the code, you wouldn't be able to have these. They obstruct the width, there's storage in the corridor, they obstruct the doors from closing. So as I mentioned, we have a PIN because obviously we're going to see these. So how do we help you have these and comply with the intent of the code? And that's what we'll focus more on today. When they're in existing buildings, that you still have to comply with code. And that comes from the existing building code section 302A.6, which indicates that those existing buildings have to be maintained in a safe and sanitary condition. Devices or safeguards which are required by CBC shall be maintained in conformance with the code edition under which they were installed. And go back for a long time, you're going to have requirements to maintain the required width of the corridor and don't store items in the corridor. So this applies to existing facilities as well. If you're introducing these into your existing building, you still have to submit the project and comply with code. And so just we're going into that a little bit more with the existing, that these are considered alterations. When you bring this equipment into the building, that's considered an alteration because of what's happening in the building again, of course. So it's an alteration to the building. So it requires a plan to be submitted. And I'll skip that last part. This obviously we're not going to read through, but this is PIN 69. So take a look on our site. If you can't find it on our site, the easier thing to do is just Google HCI pins and cans, for example. It'll take you to it. Then you don't have to search around, but it's PIN 69 that you would be looking for. It explains the background, which is part of what you're hearing here. The purpose that we have the PIN, of course, is to because these violate the letter of the code, and the purpose of the PIN is to help give guidance into how you could comply with the intent of the code and the items that have to be considered when you're looking at these. And as you can see further through, you've got A through O, so a number of not instances, but a number of items that have to be looked at. Not all of these might apply to how you're going to use these robots, but at least look through the whole list to see, hey, does this apply to what I'm doing? And what can we do to meet code? So as you know, most of these materials, these materials are already in the hospital. They're already being used. They're already being transported, but that transportation is more typically a human being, and that human can do something with, hey, there's a fire, I need to get this out of the way and go focus on the patients, or push this into the room. The robots basically have to act the same. They have to act autonomously because the staff, now you've got these robots that are moving the equipment. You have the staff whose responsibility is the patients, the human beings in the building. So they can't go take the time to move, or I shouldn't say can't, but they should not be taking the time to go Now, stop what they're doing, move, go find these carts and get them out of the way, and then go address the patient. The patient needs to be first. So the carts, these robots, have to be autonomous. I kind of jumped ahead there. So going back to why do we need plans for these, and looking at the PIN there, when you have these AGVS, they'll require some construction and remodeling, and that's also why they have to comply with code. So the new and existing both have to comply with code and have projects submitted to our office to look at these. In addition to that, you want to have the local fire authority on board. This is, and we typically, when we're helping you through these projects, we'll give you the heads up, hey, get locals on board with this, because they're the boots on the ground. They're going to be the people coming into the buildings, and what are they okay with, what are they not okay with? Like the example I gave earlier with the elevators. Do they even use the elevator in their jurisdiction, or do they just use the stairs? If they use the elevator and go into firefighter recall, then where's the robot going to be when the fire alarm goes off? Where's it going to go to? And so, as you're used to with fire life safety, we're working with us as well as with many items, we get local authority approval as well, because it affects their operations. When you have these, as I mentioned, they black and white letter of the code, they don't comply. They don't comply with code. So they need an AMC. So in addition to a project and a plan submitted, an AMC is needed. And then you'll look at the PIN, what items are applicable to how you're going to use these, and addressing those items in that AMC. So the AMC is needed with every project that has these AGVS AMRs. So I have some examples of what doesn't work and what does work. This one was actually a video too, but in this presentation I just had it as a picture. So what happened here was, as the AGVS was going through the door, you could see the cart behind it. These will stop, so they'll see an obstruction, whether it's a cart, a person, a door, another AGVS, it'll stop. In this case, it sees the obstruction, it stops. It's going through doors that couldn't close. This is a plan that actually, it's showing a plan of what doesn't work. So that you can see the little green, like neon green rectangles, those are indicated as safe park locations. And although this is blurry and it's just giving you an idea of, you can see these in corridors. So they have safe park conditions in corridors. That's not okay. These can't park in the corridor. They have to go to a room. If the fire alarm goes off, they've got to go to a room. They're going to have a storage room that they go to, the home base, so to speak, that they're going to go to when they aren't transporting items. They cannot just stay in the corridor. Now, we'll get into some specifics with this later, but as this plan is showing, as this is their home, they're staying in these corridors, that's not okay. We'll talk about, okay, they're obviously going to be in the corridor, and if it's delivering lunch, it's going to be there for a minute, or if it's for trash and staff is using it to, it's in the corridor and staff's going into the room, grabbing the trash, throwing it in the bin, it's obviously in the corridor for a little bit. That's one thing. That's going to be in use, as opposed to parked and stored basically in the corridor like this. This clearly doesn't work, right? How's your corridor width there? Who's getting through that very easily? So the items on the side, this is not approvable. There's tape on the floor. That tape is not a fire partition. It doesn't magically put up a wall that separates items stored in the corridor from the corridor. But what it does do is it gives people an idea that, oh, hey, there's this tape. I can start storing things on as long as I put it within the boundaries of this tape. That's not okay. This doesn't work. This doesn't work at all. That's storage in the corridor, and that's not even the cart. Again, what you can't see in this picture is more tape. It's saying here we have tape. We can store all kinds of things in the corridor now, so people get a wrong idea when that's there. So if you tape the area off, and that's where the cart goes, if it's if to pick up the, while staff's going to go pick up trash and throw it in the cart and then go move down to the next room. And that's where it's going to sit for a little bit. Please don't put the tape there. Could be you're going to end up with a bunch of storage that shouldn't be there. Like this. Even if you put a nice sign up that says AGV parking, keep clear at all times. Yeah, that's not clear. As you can see. The good thing is they kept that access to that fire extinguisher, but covered up that sign that says, hey, keep this clear. Here's another video of what doesn't work. And this was actually, I'm sure the facility wasn't too happy that we were here at this time, but what you'll see here is this about a minute before the video started, these carts were going through. And as I mentioned, they have these, they have the sensors on them that, hey, we sense an obstruction, we're going to stop. So you can see here, they're at a cross corridor door. You've got an AGVS on the right going through and one coming towards us on the left. So they see each other. They see each other and they stop because it's an obstruction. So they're right at the door and they're one, hey, you go. No, you go. No, you go. So they're sitting there, but watch what happens in time. And it's a little bit of a lengthy video.
This video probably about a minute after those robots identified one another.
So you can't really hear them too much, but there's a beeping that is happening that they're letting it. Oops, excuse me, sorry about that. That's not supposed to happen. Oops, that just messed everything up. There we go.
You can go ahead.
You can't hear the carts, but they're telling each other right now that there's an obstruction. So watch what happens with this person. You just kind of have to maneuver around it. Okay, normal conditions, not convenient, not great, but can they get through? Yeah, they could, but they've got to maneuver through these. Certainly not okay if you were trying to push a patient. So now what happens, because you don't just have one cart in the facility or two carts in the facility. Now this one's coming up saying, oh, yeah, you go ahead. I see you, you go ahead. So this continues to happen, and the video doesn't continue on as long as our staff were there seeing this, but these line up, and then they started lining up on both sides of this cross corridor door. So imagine this now happening on your floors, because when you're getting the company is selling these to you, they're going to show you one going nicely down the corridor and going where it needs to go, and people are moving out of the way, or it's stopping when it sees people. But when in reality, you probably have more than one, something like this can happen. So this is another example of what has to be addressed. So we're going to go through the items in the PIN and give you an idea of what at least has to be considered with when you have your plan of what you're going to use these for. So the first one, that's the AGVS unit, and use this interchangeably. The AGVS, the AMR units may not be parked in exit corridors or corridor alcoves. They're combustibles, they restrict the width, etc. The AGVS may not be used in an exit corridor for charging, staging, or other moderate long-term duration or uses. It definitely not storing these in the corridor, or excuse me, charging these in the corridor or storing them. Or like I said, moderate or long-term duration uses. And what is that? You can see we don't have a time here. Is it okay to sit for 5 minutes? Is it okay to sit for 20 minutes? How long can these sit there? That's going to be facility and project specific. How are you using them? The lunch facility, they came up with, you know what, we're not going to need more than 5 minutes. The cart's going to come up, it's going to be outside of the room, and staff's going to take the tray, walk into the room, come out, go to the next room. So we won't need these any more than 5 minutes. So what happened with that facility is they came up with that. That was their limitation, 5 minutes. Then if it doesn't move and it's now 6 minutes, then that machine is programmed to go to its room or it go to its home base, wherever it's programmed to. When I say go to its room, we are looking for, if these are going through smoke compartments and they're on patient floors going through smoke compartments, then each smoke compartment should have a room for this robot or robotic device to go to in a fire alarm condition. And it needs to go there by itself, get in the door. If the door is a door that's required to be closed, have that auto closer on it as well. That ends up having to be tied to the fire alarm system, smoke detection in that room. So again, if these are on patient floors, going through different smoke compartments or going through a smoke compartment, then they should have their own room to go to in case of an event of a fire life safety nature. I will talk more about that as we add on to these. The second one, the units should be autonomous. Again, ensuring patient, staff, and visitor safety is the hospital's primary responsibility. It takes time in a hospital where you're relocating versus evacuating. It's not a get up, get out when the fire alarm goes off. It's a relocate to a safe area. If staff have to take the time to move these, get them out of the way of the doors, get them out of the way of the corridor, and then go start moving the patient, that adds a significant amount of time that you just can't have. Smoke travels too fast and kills too quickly. The use of AGVS units in corridor systems serving the general public and patient care areas should be minimized. Indicate the minimum guide path clearance that will be maintained. So we saw with some of the examples there in the lower, what appears to be lower levels of the facility. Some facilities just have them in the, what I call like the guts of the building, where they're transporting from the loading dock on. Sometimes they're just down there. Now they still have to comply with the requirements to keep the exit path clear, but there are different allowances that would be there versus if they're on the patient floor. So again, letting us know what you have, how you're using it is huge, and having us help you figure out how to become code compliant. Again, the minimum egress width has to be maintained. The corridor system and adjacent rooms that contain the AGVS system have to be provided with smoke detection. The AGVS unit storage room, their home base where they go to get charged, that is going to need smoke detection and sprinkler. And the AGVS, it needs to be programmed so that the door to that storage, that homeroom, doesn't open if the smoke detection in that room has been activated. So if there's a fire in that room, because again, you've got that battery, that charging and the battery storage there. If that fire happens in that room, we certainly don't want these AGVS to come up because they're told to go to their home base, they made their delivery, and then they open up the door, and of course that's not a good thing. So these have to be programmed so that if that detection in that room goes off, they don't go into that room, they go to their backup room. The doors to that room, their home base room, have to be equipped with auto openers or auto closers that are connected to the essential electrical system so that they continue to operate obviously with the power outage. And then smoke detection will deactivate the power operators, and then power operators required to activate during fire alarm for AGVS transport will require approval of the fire alarm matrix for sequence. So of course this is you'll have fire alarm drawings that have to come into play. We'll see a matrix of events that happens based on how you're using these. And a protection of the battery storage charging rooms have to comply with Chapter 12. That this is based off the 2022 edition. So in Chapter 12 of CFC, there are requirements for battery storage rooms, and it's going to be based on the type of battery being used and the amount of the capacity of the battery and how that room has to be protected. However, at a minimum, it's going to be sprinklered with smoke detection, and then the rating that the rating it will need will be based on the code and the size, what you have in there, and the amount of what you have in there. To allow passage of AGVS units, the activation of the auto closers or reclosure of smoke and draft control assemblies and fire assemblies should not exceed a delay of more than 10 seconds from the time of smoke detection activation. A closure or reclosure delay of 20 seconds may be permitted with a reduction in the spacing of required smoke detector protection. So as I talked about, these are going through the corridor, going through fire rated doors, smoke barrier doors, cross corridor doors. They're going through those, then it's going to take some time. So we've had some programmed where they come up to the doors if the fire alarm goes off, and if the unit is closer than 5 feet to the door, then it'll go through the door. If that's the plan and that's what's being submitted on the AMC, great, but that's going to be tested that way too. So we'll test the fire alarm with those units that close to the door. And if they cannot push through the door, because we've had some companies say it'll go through, it's fine, it'll push through the door, it's okay, they'll be fine. We have others that they're more than 5 feet from the door and the fire alarm goes off, it'll turn around, it will not continue to go through that door, it'll turn around and go to its room, go to its designated room in that smoke compartment. If it's going through the door and say, hey, if we have a delay, so it gives it time to go through the door, can we do that? Sure, we could delay 10 seconds and like this says here, potentially 20 if you need a little bit more time, but if you go to that 20, then there's going to be additional detection required. So it's that give and take of the code, like, okay, sure, you can do this, but give us this in return, so there's a little safety there. So, a little bit similar to the last, where AGVS carts pass through exit doors or exit access doors, basically any of your doors. Such doors should, because the exit access is everywhere, right? Such doors should be provided in pairs. And then AGVS cart must not obstruct more than 1/2 of the required opening width of such openings, and it must not obstruct the doors from completely closing. AGVS should confirm the path is clear prior to entry of the door width, and the status of the AGVS carts during a fire alarm condition must be addressed, of course. It should be demonstrated how AGVS carts will be programmed to proceed to holding rooms equipped with smoke detection and auto openers and auto closers connected to the EES, and whether they will remain in elevators or vacate elevators. And it should also be demonstrated how the AGVS unit is programmed to return to its designated holding room and not pass through cross corridor doors in response to the fire alarm when approaching cross corridor doors that have been released by activation of smoke detection at the cross corridor door. So again, reiterating what I said before, if it's going through cross corridor doors, it's either got to make it through with potential delay of an allowed time and added detection, or it turns around and it goes to what I talked about before. It has its designated room and its smoke compartment. That room's going to have smoke detection so that if that's the room of fire origin, it doesn't go to its designated room and open up the door. If that does, then it's going to have a backup location to go to. Otherwise, it'll go to that room, it gets to the door, it's programmed so that the door opens when it gets to it, closes behind it. So again, that's all programmable. It's got to be autonomous. When the AGVS cart stops at a fire door that has closed in response to a fire alarm, a clear zone equal to at least the required minimum corridor width must be maintained at the approach to the closed fire door or doors, and the AGVS should proceed to its designated holding room within the smoke compartment. The AGVS should not traverse cross traffic during the fire alarm. The AGVS should stop momentarily and then proceed to a safe home base. And then it must be demonstrated how the AGVS units are programmed to discontinue travel if fire is within the contents of the AGVS cart. So something else to think about is not just is the fire occurring in a room, in a space, a smoke traveling back and forth, smoke compartment, but what about the unit itself? Is it's transporting soiled utility and there's a fire on the unit itself, on the cart. You don't want that traveling down your corridor, spreading smoke, going through your doors because it's programmed to go through them. So addressing what's going to happen if an incident is actually happening on that cart. The AGVS should not be capable of opening a fire door at a location where a smoke detector has activated, of course, right? Common sense there. If that's where the smoke detector is activated, then that cart should be going through there, should not be opening that door. The fire alarm will shunt the power operators and door functions, and any door operations during the fire alarm will require approval. The AGVS cart must not interfere with the operation of elevator recall. For AGVS in a recalled elevator, programming will need to address function of AGVS at the recalled floor, and that again requires local fire authority approval. So these are programmed to make their way to the elevator. The elevator, no one's there pushing the buttons for them. It goes to the elevator and goes where it needs to go. So say fire alarm goes off, it's going to the elevator. Now the elevator's taken to recall floor. The thing's going to be confused. This is not what I was told to do. This is not my home. What do I do? So it's got to be programmed to deal with those situations, as well as, like I mentioned, with the local fires coming in and they're using those elevators to take control of it. They probably don't want to share space with this thing and their equipment. So does it go, fire alarm goes off and it was going to the elevator and now it's going to reroute to its room, or it's going to reroute to an office somewhere just to get out of the way until it can continue on? You know, how are you going to work with this? So just, we'll work with you with the ideas. Cart must not exceed the weight limitations of an elevator, the floors, ramps, etc., or any other spaces it traverses, stops, or is parked. These can be pretty heavy depending on the load that they're carrying, or they can be super light. So if you have super light ones, it's probably not going to be a problem. If you're using it for heavy loads, we're going to have to look at this. And then for structural loads, the strength of the structural load bearing members should be evaluated when an AGVS is considered. Again, how are you using these and what kind of load is going to be on this, and is it going to affect any structural load that needs to be considered? And then in accordance with Title 19, Section 202, a review of alternating designs or methods of construction or alternate means of protection involving fire life safety issues requires local authority approval. So as I mentioned, these don't comply with code. We are clearly working with facilities and have worked with facilities for years and years on how to use them. We're not going to say, hey, no, you can't have these, it doesn't comply with code, go away. No, say do an AMC, show us your plan, talk to us, let us know how you're trying to use this, and let's work together to find a way that you can get these in how you want them. So now we have some examples of what does work. Now this is older. This is one of the AGVS. It's a bit older, where it's just going down this path. You can see that's not the track on the floor that you're seeing there, but that is its path. It's traversed it many times. This is older, but this is a facility that decided to use a space strictly for the AGVS, and that's an option. We have a couple facilities like that actually, where they created a corridor only for the AGVS, so it's not interfering with people, or not too frequently at least. This facility created basically 2-hour enclosure, this whole floor, 2-hour enclosure. So you essentially have this big storage room, right? They have their own elevators for the carts that only the cart goes to, so they don't have to worry about sharing it with people or sharing it with firefighters, which are also people. This one, oops, I thought that was a video, but that's not. So you can see that elevator is pretty small. It's meant just for that AGVS. This is basically the storage. Again, this facility, it's 2-hour all the way around, top, bottom, sides. So it's a big storage room. So their loads that they pick up, these different carts that they pick up, it's okay to have them stored there. You can see there's still a path in case somebody's up there, they can get through. But that's okay to be stored up here because they treat it like this, like a big storage room. So just an example of it, making its way to it picked up its load. The next one picked up its load. They're making their way to their own special elevator. So again, completely autonomous. They don't have any human beings helping out with this. It's just, they pick up their load, they get it, they go in the elevator. This one's gonna wait its turn. So similarly, when they're on the floors, they need to, again, operate it autonomously. So just gives you a little idea of how that works there. Whoops, sorry about that. You saw that already. And that's another one. So this one, there's people, you see somebody there. Now that person's out of the way, but if that person were standing in front of it, it would have stopped. It would have seen that person and it would have stopped. And when they stop, how many inches, feet, etc., is different for each one. But there are many safety devices that have to come into play in the manufacturing of these and regulations that they have just to create them. So those are in place there. Then just this is the whole corridor that it would go down. Anyway, so can these be done? Yes. Again, letter of the code is, hey, you wouldn't even be able to have these, but that's not how we work at Oshpod or HCI. We work with you to figure out, all right, you have these, how can you have them and have it comply with code, and how can we help you get there? Please, please, please talk to us. You start off with the pin, look at pin 69, look at the items, think about how you're using them, the path that it's going to travel. You know, you're going to have one per smoke compartment. Is it even going on the patient room floors? Are staff going to be with it when it's in use, and that staff designated only to that? Is it going down a corridor that, when you're thinking about the timing, you've got, say you're going to use it for trash, and it's going to sit in one spot on a floor until it's told, okay, go to your home. Okay, well, what is that timing? What does that look like in trying to figure that out? How many rooms are on that floor that our trash is going to be picked up from? And then how long should that take? How long should it take to traverse where it has to go to its home base? Yeah, all kinds of things that we'll look at and help you figure out what you can do to get this to work in your facility. Existing, when you put this in an existing facility, really difficult to comply with code, but not impossible. It's just really difficult. When it's in new, great. Design the building appropriately to take these into consideration. Again, just general, but it's going to differ based on the variables that you have. But the general is, they're in the smoke compartments, then they have a room in each smoke compartment that they can go to all by themselves. And when a fire alarm goes off, that room is going to have smoke detection, auto openers and closers that work with the fire alarm system, and that knows, hey, oh, I can't go in there, my room's on fire, I got to go to my second room. And where's that second room? Could it be, what can these rooms be? Maybe it's an office. It goes to an office. That's where it hangs out in case a fire alarm happens. It's not where it normally stays, but it's where it goes if a fire alarm happens. Now, you wouldn't want it in a room like a soiled utility room or an incidental use room that's required to be rated and have the self closers, because those are going to be the rooms that are most likely to have an event happen in them. So you don't want that going into that room, and well, it wouldn't be able to go into there if that were the one on fire, because I'd have to go to a second room, but those would be a little bit harder to deal with. So look at some other rooms that they could go to, but watch where they're going, because the occupants in that room have to get out of that room. So we've had some that have used waiting rooms that are of a pretty significant size, and it just finds a corner in the waiting room, but it doesn't obstruct the path for the occupants to get through. Anyway, like I said, all kinds of variables we could talk about forever. Just let us know what you have. Please talk with us and what your specific needs are, and we'll help you work through that. And submit the AMC. Please don't forget the AMC, because it doesn't comply with code. We need the AMC. So at that, we have a few minutes for questions. So I think, Monica, are you sorting through the questions, or would?
Yes, going through the questions. Thank you, Nancy. I mean, it was wonderful. You always have the amazing presentation. So let's go through. There are, again, we don't have much time, but let's go through the questions that are on the go to questions tab. In California, is HCI seeing an increase in the use of the AGV and the MRRs? Is there any data on use across the whole hospital in California?
We don't have data as far as how many are using them, but yes, we are seeing these more and more and more. Like I said, 10, 15, or not 10, but 15, 20 years ago, it was just too hard because they didn't have the programming capabilities that they have now. It was too hard to have those and have them comply with the intent of the code. And then actually the poor individual says that an individual came to us that, I don't know if he was like the first one that had these or whatever, but the poor guy walked away saying, I'm only going to use these at hospital pools because it's too difficult for, or excuse me, not hospital pools, hotel pools, because it's too difficult to use in a hospital. But now it's much different. These are so programmable. We do see them in many of our facilities. Now we do see them in facilities that don't have a project and bootleg them in, and we have conversations with those facilities so they get the projects in. But yes, we see them more. As far as how many, I don't know that, but they're in use much more in significant amounts than they were before.
Thank you, Nancy. Thank you for the answer. There is another question. This is kind of related to also to the PIN 68 for the mobile equipment, the section D, and the question says, does HCI want any indication on compliance, corridor width, AMR travel width on drawings?
Yes, definitely. Showing us, so if they're just moving straight through, we still have to show that width. Your corridor width's going to be shown anyhow, but yes, what's the size of this unit? How much of that corridor width is being taken up? And then again, coupled with how. It's just moving straight through. Is it stopping every so many feet to deliver an item or to have an item removed for it or put into it? But yes, that's to be shown on the plans. Thank you.
Thank you. And yeah, makes sense. Next question reads, due to the battery storage in the AGVs, are you required to have direct exhaust venting in the storage room?
So great question, and thank you for thinking of the batteries. That's a huge thing. The battery storage requirements have changed significantly through the recent additions of the code. So what you used to find in Chapter 6 in CFC, and even before that, incidental uses in CBC, that's changed for battery storage, and that significant changes happened in mid-cycle 2019. Please go to CFC, the fire code, and look at Chapter 12. You're going to be looking at more chapters, but start there. Look at 1207. Know the type of battery you have, the amount of the capacity, and then look at the requirements that would be in place for that use. So it's going to depend. So that you know, our answers are always it depends. It depends on what you have and how much you have of it, and what code requirements come into play based off of that amount.
Thank you, Nancy. Next question reads, is an AGV plan including storage location and staging areas need to be part of the fire life safety plans or as a separate submission?
Part of the fire life safety plans are fine. So some people submit the plans just for these. They're like, oh, we already had these. We're going to submit these plans because we didn't realize we needed them before. That's fine. Just submit the plans just for that, but show all these components. Or, hey, we know we're going to have these and we're going to include this in our whole plan submittal. That's fine. Submit them with the whole plan.
Thank you, Nancy. A few more questions. We are 6 minutes away from the end. Next question reads, how are you? Can you hear me?
Yes, 1 second though. Let me go back to that one.
Yes.
As well, it's this question asked for the fire life safety pages. Please note that the items regarding these units are going to be on multiple pages. You'll have fire alarm information we need on fire alarm drawings, on the A pages. It's going to be all over depending on what we're talking about, the wiring, electrical. So you're going to have pointers on all different pages. What we've had some people do is group the plans that are specifically related to these and just group them all together in one part of the package, kind of like you would for like a hood suppression system, that's okay too. And that maybe that makes it easier. So I just wanted to add that, Monica. Sorry to interrupt you.
No. That's that's wonderful. No worries. Next question reads, do the vendor building the units in compliance with the California code, or they are generically complying with the codes?
So there's a standard that the manufacturers have to meet to even build these. So there's a whole different ANSI standard. I think I have it in the pin. They've got to meet that just to build these. And then as far as how to comply with code, they can help you understand what their machine can do and how it can be programmed. So you'd want to be in conversation, have conversations with the vendor, as well as your fire alarm individuals, your architects. Everyone's going to be on board with this because everyone's going to have a piece to play with getting this to work how you want it to. And the vendor can help. Hey, ours can be programmed to do this, this, and this, or they weigh this much, so they can make it through the door in this amount of time, or push through the door, or whatever. They can help you with that part of it, and help the fire alarm contractor also determine what they need. You know, we need it to do this in a fire alarm event at the doors. We need its own door to do this. We need the elevator to do this. They're going to need to be on board with each other. So it won't be the vendor alone. They're just going to tell you what their machine can do and the capabilities of it, and then everyone else will put their hats on and work together to get it to where you need it to be.
Teamwork. So this one ties to the next question: who will be responsible for verifying all the parameters of the vehicles?
Ooh, that's teamwork too. So just like anything submitted to our office, a design professional of record is responsible for ensuring that the plans have everything that we need on them, and for working with us to help you get what you need on those. And then it'll go through the review process, and we'll verify that what you have and what's on there meets code. And the same with the AMC, verify that what you need on that AMC is there. So again, please work with us first, because there's, as you can tell, there's so much involved with this. Please talk with us first before doing the AMC, so you don't get it back 5 times. And but now we don't, not hand holding, I don't mean like that, but we can certainly assist to make this a little easier for you.
Thank you, Nancy. What are the typical services provided by the robotic in the hospital? That is, nutrition, bring to the medical supplies to the unit. What are?
I'll say yes. we've seen for that, like like I said, for the lunches, medications, soiled linen, trash, the little doctor robots. I'm sure that's not their name. I'm sorry, that probably didn't sound very professional, but the robots that are the doctors, and they'll go around and take the stats from the patients. We really have just seen all types of uses, and I'm sure, like the floor cleaner. I mean, I haven't seen that one in particular other than the slide that I showed you, but yeah, that's a floor cleaner. That's another one that can be used. So we really see all kinds, all variations.
Thank you. Last question. How are you classifying charging rooms, as an F or S1? And if there are fire sprinkler density going to be raised?
So again, this depends, right? The room, how that's classified and rated and separated is going to be based upon the type of battery the type of battery used, and the capacity of the material, and the code will determine that. So if it's the amount that exceeds the tables in the amount shown in 1207, then yes, those are considered F1s and are required to have a 2-hour fire barrier, and any glazing in those walls, if you have those, which just probably don't. But anyways, I can't tell you to do that. If you have them, then it has to be the fire resistance rated glazing, the glazing that's tested as a wall per the ASTME 119 UL 263, not the fire resistance rated glazing. It's got to be fire, excuse me, I just said that backwards. But anyhow, it has to be the glazing that's tested as a wall. So watch with those. But again, whether it's an F1 or an S is going to depend on the amount and type of battery stored in the space and what the code requires. So again, C1207 in determining that.
Wonderful. Nancy, thank you so much. And this brings us to the end of our presentation, and we hope you all found this webinar to be helpful. Please remember, if you didn't download the PDF handout, you can find it and download under the handout section of the GoTo toolbox. If you have any question about the presentation, send those questions over to the Regs unit at hci.ca.gov. Spelling is REGSUNIT at hcai.ca.gov. It's been a pleasure being with you all today. Thank you for what you do and for doing your part in providing access to safe, quality healthcare environment throughout the state of California. And until the next time, have a wonderful day. Bye, all.
Thank you, everybody. Thank you, Monica.
Mhm.
Bye.